In this interactive application, we are going to review the installation process for two types of storm drainage pipe products: reinforced concrete and thermoplastic. After all geotechnical studies are completed, the installation process begins by bringing the required equipment on site. The use of machinery with a sling is required at a single point for plastic pipe with a diameter of 24 to 36 inches and at 2 points for a diameter above 36 inches. The proper method of lifting concrete pipe utilizes a lift hole that is part of the structure of the pipe. This lift hole makes for easier handling by positioning the pipe for installation. There are two types of concrete pipe: flushed bell and flared bell, also known as RG. In this interactive experience, we will be focusing on flared bell pipe, as these have additional requirements to consider. The trench must be wide enough to ensure that compacting equipment can be used without any obstacles. It must be wide enough to properly compact material in the haunch areas. Trench widths will vary depending on the type of pipe, the diameter of the pipe, and the relevant installation specifications. The foundation must be evaluated to determine its condition and suitability. A stable foundation must be provided to ensure proper line and grade is maintained. On a live job site, the excavator would be positioned in the front of the pipe so progress on the trench can continue. For optimum visibility during this AR experience, we have placed the excavator on the back side to allow for the clear visual comparison of an engineered product and an engineered installation. We'll now show the process of excavation and installation on an existing pipe installation. This installation must be done following the manufacturer guidelines, all relevant ASTM and AASHTO specifications, and according to OSHA guidelines. For trenches deeper than 5 feet, OSHA requires trench boxes be utilized to ensure worker safety. The installation method for rigid and flexible pipe is different. For HDPE pipe, all excavation below the pipe crown elevation should be done from the inside of the trench box. For plastic pipe, this is a time-consuming process that has to be done carefully, as the trench box has to be raised vertically after each lift of the embedment material to ensure adequate completion. For concrete pipe, this is not a concern. For ease of visualization in the following process, the trench boxes won't be visible. After the trench has been excavated and a solid foundation has been established, bedding material should be placed using soft soil according to the manufacturer's installation manual. This soil material is loosely placed and shouldn't be compacted. Make sure bedding follows grade level for bottom of pipe to ensure continuous support along the barrel of the pipe. The pipe is prepared for installation. The joints are cleaned, lubricated, and the gasket or joint sealant is properly placed in the spigot. The pipe is then lifted and carefully installed. The concrete pipe installation method utilizes a homing process, which utilizes the excavator pushing gently on the end of the bell to properly home the joint. For HDPE pipe, the connecting and homing process can be achieved by placing the installation stub in the bell of the pipe, then placing a wooden block so a worker can push against it until the pipe is fully inserted into the bell. The pipe needs to be at proper grade prior to homing the joint to prevent the contractor from pushing down on or moving the homed pipe to attain grade. This, and placing a wooden board between the pipe joint and the excavator bucket, will help protect the joint from damage during the homing process. After the pipe is correctly installed, the lifting equipment is disengaged and the lift hole is plugged. After the homing of the pipe comes the process of adding a backfill with granular soil by lifts. As this backfill is placed around the pipes and into the trench, it has to be compacted, making sure it fills the haunches and keeping the pipes from shifting. Structural analyses have shown that structural backfill for concrete pipe is only critical up to the spring line or the center line of the pipe. An additional structural backfill is only required if heavy equipment is going to transit over the pipe. Lifts of 6 inches each must be done alternating from one side to the next and compacting using the proper equipment. For a flexible pipe, this process has to be performed using smaller lifts from 4 to 6 inches when utilizing a trench box, making sure the backfill is properly placed into the haunches. It's very important that backfill soil selected fits into the corrugations of the flexible pipe, as very little of the structure has been built into the flexible pipe. A properly distributed and compacted backfill provides 90% or more of the structure for plastic pipe installation and requires the design engineer's supervision and inspection. The requirements of an engineered installation are different from a concrete pipe, which often has 90% of the structure built into the pipe, independent of the installation. In a proper corrugated plastic pipe installation, the structural backfill material must fully encapsulate the pipe, including being placed into the haunches and in between the corrugations of the pipe. To properly ensure the backfill is adequately placed between the corrugations, a manual placement process is required. This critical process is known as knifing, as a worker must make sure that the backfill material gets into the haunch and into every corrugation of the pipe, because the backfill provides at least 90% of the structure for a flexible pipe. The claim of faster installation of flexible pipe versus concrete pipe may often be explained by having this process omitted. A greater amount of compacted structural backfill material must be used for HDPE pipe, a minimum of 12 inches above the crown of the pipe, to provide the structure for the installation and prevent excessive deflection. To obtain warranty coverage on a plastic pipe product, all applicable standards, specifications, laws, and the manufacturer's installation requirements must be followed. After the pipe has been installed and graded and the backfill compacted, the overfill material is lifted to finish the installation. In the case of concrete pipes, the process is faster because the backfilling and compacting of the structural fill has been finished by the spring line of the pipe. The rest of the trench can be filled with the overfill material. It's also important to note that plastic pipe weighs less than concrete pipe. While this is beneficial during handling and transport, adequate backfill coverage is critical to avoid shifting or floating. Because flexible pipe requires an engineered installation, the proper installation technique is critical. Without adequate structural backfill and the correct knifing and compaction of the backfill, the storm drain pipe can be compromised. Care must be exercised during installation to mitigate the greater risk of excessive deflection and potential collapse. When designing drainage systems, consideration should be given to the natural hazards of the region to ensure the pipe fulfills its projected lifespan. For example, in DOT applications or fire hazard severity zones, plastic pipe can melt or burn from common brush fires or fires caused by fuel spills on roadways. Additional geographic considerations include high water tables, fault lines, soil type, or hurricane-prone areas. Reinforced concrete pipe is a rigid engineered product where the structural integrity specified is built into the structure of the pipe upon delivery. Plastic pipe, on the other hand, requires an engineered installation due to the primary structure being the soil envelope. The engineer is required to be involved in the construction activities and is responsible for the post-installation deflection testing and documentation. In this scenario, an improperly installed plastic pipe may be rejected by the engineer because the engineer shares the liability for the installation integrity to fulfill the contract objectives. Deflection testing should be done 30 days after installation. This additional labor time and volume of backfill material can add significantly to the cost of the pipe installation in comparison to the pipe itself. When comparing the proper installation procedures and guidelines, concrete pipe can be installed faster than flexible plastic pipe products. Contractors and engineers must be aware that cutting corners during the installation of a culvert pipe may create inconveniences, like voiding the manufacturer's warranty, a shortening of the pipe's life cycle, additional maintenance issues for the owner, and can create social disruption and even danger to the public. Due to the costs of proper backfill and the additional labor required for proper knifing procedures, claims that flexible pipe is significantly cheaper to install than concrete pipe should raise concerns to engineers and owners that the proper installation guidelines are not being followed to ensure the backfill structure can meet all applicable specifications, standards, and contract requirements. Thank you for joining us on the TCPA Augmented Reality Experience. If you have any questions or comments, please fill out the contact form available within this app. If you enjoyed this experience, please take screenshots of the app in action and share these on your social media platforms.